I've been trying to give this talk for quite a while, and I think it's getting better. And so, if you have any questions, don't hesitate to interrupt. Let me start by pointing out that war is too serious a matter to be left to generals. And for that reason, the commander-in-chief in our country is a civilian. He is elected by us. And so in some sense, we have a say in matters so serious that people get killed. And my thesis today is that global warming is similarly too serious a matter to be left to scientists, that we need the participation of everybody. And I argue that the evidence in favor of that statement would be a picture such as the following one, which you can see if you look up at the sky this evening. And it's basically a picture of the Milky Way. And you see a lot of stars, and some of these stars that you see are actually galaxies. So they are literally billions of stars. And astronomers now tell us that many, many of these stars have planets. They have solar systems, and that there are any number of planets similar to the Earth out there, with one exception, that of all those planets and stars out there, there is precisely one that's known to be habitable, and it's this one, planet Earth. So every time that the astronomers, and it usually makes headlines in newspapers, when they tell us that they've discovered more Earth-like planets out there, this particular one becomes even more exceptional, because it's the only one known to be habitable. And it should, for that reason, its future cannot be left to scientists, Earth scientists. It's something in which everybody should be involved. And there's the rub. In this room, global warming is the big issue today, but if in this room I ask people on their opinion concerning global warming, most of you will agree it's cause for concern. However, if we step out in the streets in St. Petersburg or Tampa, we quickly find that global warming is a very polarizing situation. And as I said, everybody ought to get involved. And so it's a major puzzle. This is the only planet in the universe known to be habitable. Why are we so polarized? Why is there such a difference of opinions? And in principle, we should applaud people such as Al Gore and Michael Crichton, neither a scientist, who took the time and the trouble to familiarize themselves with the available facts, and they took the trouble to inform the rest of us. They deserve applause for that. And the only problem is that they disagree completely. Gore tells us that we should, this picture showed not only is our planet exceptional, it's also singularly unimpressive. That if you were to visit the solar system, you'd be much more impressed with Saturn or Jupiter. Earth is this tiny little dot over here. And nonetheless, that's the dot that deserves all the attention. So it's in trouble, according to some people. And Gore states that, and I assume you've seen a movie called Inconvenient Truth. On the other hand, there is a novel, not a very good one, by Michael Crichton called State of Fear. You can find it in supermarkets. It's easy to access. I recommend you read the appendix. He has a short appendix, 3 pages long. It's worth reading. In it, he gives his reasons for doubting that global warming, in fact, he states quite firmly it's not cause for concern. And so we have this peculiar situation. We are on the only planet that's known to be habitable, and we can't agree about how to cope with possible future threats to the inhabitability of this planet. For advice on how to proceed, we can then watch a movie by Clint Eastwood. It's a movie called Invictus. You may have seen it. And as movies go, it's not that good, but I recommend you see it. It's not that good because it's about a game called rugby, which just personally I find rather boring, but nonetheless see this movie because it tells the story about how Mandela was faced with a very polarized country when he became president. It was so polarized, civil war was expected, and a few million people emigrated in the expectation that there would be a civil war. Unfortunately, they were all young, all highly educated. It was mostly young white youths. It's exactly the people the country could not afford to lose. They left, and Mandela was left with the situation. How do you restore unity in this country? And he used the game of rugby. There happened to be an international rugby competition in South Africa the year after he became president. And he decided that he could use this game, if South Africa could win the tournament, he could use this game to unite the country. And these politicians repeatedly have used sports for these political purposes, so there's nothing novel about that. To Mandela, the big challenge was that in South Africa, rugby is a symbol of oppression. It's a game played by white youths. Black youths play a game called soccer. If you're curious about the difference between soccer and rugby, soccer is played with a round ball and rugby with an oblong ball. And humans being what they are, that scores for considerable strife. People disagree completely as to the significance of these two games. So Mandela had a tough situation. The white team at the time, incidentally the South African rugby team is entirely white. If you watch the soccer, the last World Cup, the South African soccer team was entirely black. Anyway, Mandela had to democratize rugby, get everybody interested. And you cannot love that which you don't know. Okay, so you have to learn something about rugby. And Mandela himself had to learn the rules of the game, the strategies, the star players. And he had to persuade the white rugby players that they were capable, as a mediocre team, that they were capable of winning this tournament. And that they had to assist in telling, especially the black youth, about this game of rugby. And so they went to the slums and played games. The movie is about that. The movie is worth watching, not for the rugby games, but it's an accurate portrayal of social life in South Africa. So for that reason, it actually is worth seeing. The end of the story is that the team wins and Mandela achieves. So the movie ends happily. Mandela basically repeated the exercise a few years later with the World Cup in soccer. Could a poor black African country successfully organize an event as complex as a World Cup, literally millions of people come and so forth? And they succeeded spectacularly. Everybody who visited, it was in 2010, I think, and everybody who visited the country was much impressed, and it gained good publicity. So if we now go back to global warming, if we want to find out what went wrong with Crichton and Gore, why do these two people disagree so completely? And what I find fascinating about it is the two are actually very similar. Same age, same social background. One went to Harvard, one went to Yale. Highly intelligent people. They both assure us they love the environment, they love nature. How can they disagree so completely about something as important as the future of the planet? And if you think, presumably they know science, and on the basis of the Eastwood movie, Mandela's experience, one could say that what's needed is to democratize science. So it turns out it's easier said than done. So I want you to watch briefly a video that will explain why it's easier said than done. This video will convey, it's about Harvard. Let's just watch it and we can comment.
Are you ready?
Yeah. Sound.
Truck sound?
Despite a lifetime of the very best education, students in our classrooms are failing to learn science. Many of these students will graduate from college with the same scientific misconceptions that they had on entering grade school. To test how a lifetime of education affects our understanding of science, we asked these recent graduates some simple questions in astronomy. Consider, for example, that the causes of the seasons is a topic taught in every standard curriculum.
Okay, I think the seasons happen because as the Earth travels around the sun, it gets nearer to the sun, which produces warmer weather, and gets farther away, which produces colder weather, and hence the seasons.
How hot it is or how cold it is at any given time of the year has to do with the closeness of the Earth to the sun during the seasonal period.
The Earth goes around the sun. And it gets hotter when we get closer to the sun, and it gets colder when we get farther away from the sun.
These graduates, like many of us, think of the Earth's orbit as a highly exaggerated ellipse. Even though the Earth's orbit is very nearly circular, with distance producing virtually no effect on the seasons, we carry with us the strong, incorrect belief that changing distance is responsible for the seasons.
I took physics, planetary motion, and relativity, electromagnetism, and waves.
I've never really had a scientific background whatsoever, and I got through school without having it. I've gotten very far without having it.
I had quite a bit of science in high school, yeah. Physics, first year, and 2 years of chemistry.
Regardless of their science education, 21 of the 23 randomly selected students, faculty, and alumni of Harvard University revealed misconceptions when asked to explain either the seasons or the phases of the moon.
When it's further away from the sun, then it gets colder.
The Earth's position interferes with the reflection of the sun against the moon.
Just stop there. You got to stop there. Oh.
It's going to be a Princeton.
Okay, so what we saw there's a sort of one good thing, one bad thing. I'm on the impression that the main goal of education is to build self-confidence. And so here we've seen it taken to an extreme. Especially the professor at the end, with complete self-confidence, tells you complete nonsense. What I want to do in this seminar is to go back to the girl. Just before the professor spoke, there was a girl who assured us that she had no science background whatsoever, and it's done her no harm whatsoever. And so how do we persuade this girl that she ought to learn some science? It's to her benefit. How do we tell people in general? And this, I feel, is the bad thing about the movie. The movie's gotten a lot of attention. There's been videos about the video. There have been conferences about this. And somehow they all missed the point that they confused about what science is. And I would argue, how do we persuade it? And so the movie, from my perspective, does harm. And as I said, they've had conferences to follow up on this. And it was mostly self-congratulatory, how much courage they had to release this. They didn't want the world to know, and so forth. But there was no attempt to answer this girl who says that for practical purposes, you're not handicapped if you don't know any science. And she has a point. Why do we insist people know that the axis of the Earth tilts? I mean, it's sort of a useless thing to know. Why do we insist children should know this? And my big objection to the video is that it gives the impression that science is a collection of facts. And it's a bit like a game of Jeopardy on television. If you ask some question, it has the right answer and the wrong answer. And if you know the right answer, you're smart. And if you give the wrong answer, you're dumb. And after a while, if you watch this video, it goes on for quite a while, you feel sorry for the students. It's as if they were being set up to feel like fools. And so my main message for the students is there really is nothing wrong with giving a wrong answer. And that one of the advantages of learning science is that most of the answers you give and even answers you read in journals are wrong. Science is not a collection of facts. And I would say that science is organized skepticism. So I'll divide the talk into three parts. The one is, that if I had to answer this girl, I would give her these three aphorisms. I would explain that science is poetry. It enriches your life. It tells you that there is amazing unity behind the great diversity of phenomena we see in nature. Secondly, to remember that science is organized skepticism, that it teaches you to question. And that's where the self-confidence comes in, that it's extremely important to have self-confidence so that you can question accepted beliefs and theories. And it's of benefit to everybody. If you're a pastry chef or a taxi driver, you should question your recipes, make some changes, question the routes you take. So it's a lesson that's applicable in all aspects of life. It's a very valuable lesson. And then the third most important thing to learn about science is it has severe limitations. It does not tell you how to live your life. Right? It can tell you how things work. And this is a paraphrase of something Galileo supposedly said to the Pope when they got into an argument. But Galileo basically told the Pope that science can tell you how the heavens go, but not how to go to heaven. That's the Pope's job. So I'll go through each of these in turn. And let me start with the first one. So we have to find, so we see a great diversity of phenomena just looking around. People in this room represent a great diversity of phenomena they study. And our approaches can be broken into two categories. The one is the reductionist approach, and the other one is the holistic approach. And the reductionist people try to identify laws that govern all these natural phenomena. So something that appears quite random is not quite as random as it seems if it is in accordance with certain basic laws. And it started out with astrology. People noticed that the stars usually move in circles at night around the pole star, except there are things called planets. They behave arbitrarily, and I'm sure everybody in this room knows his or her zodiac sign, and so astrology is still well and alive. We like to believe there is order in the world. And Newton was the big advance in that he wrote down some equations, and the equations had a term for something called gravity. And Newton, we all know apples fall down because of gravity, but Newton extrapolated wildly and said it extends all the way to the moon, to the sun, throughout the universe. It's an amazing extrapolation, and wrote down these equations. So nobody would believe gravity, but Newton's results were in such amazing agreement with observations that in his lifetime Newton became famous. A completely different approach is if you ask how did we humans get to be here, it doesn't help to write down a few equations and solve them. You look holistically, gather a lot of facts, and look for patterns, and you end up telling a story. So Darwin told a story, and the story has become quite complicated. This is the family tree of life that Darwin originally proposed, and with recently paper in Science using DNA molecule genetics become much more complicated. Sort of intriguing. We humans are somewhere in here. Each of us host quite a few bacteria. I think something like forgotten 10% of your body weight are bacteria. So they're really dominant. But anyway, we've gone a long way. And how did life presumably started at the top there and then got more and more complex. If you ask how that happened, what's the context for it, you have to go to this gentleman Wegener. And it turns out the unifying theme for that is basically plate tectonics. That if we go back to the question, we want to know why the planet is habitable, we have to explain not only why it's habitable today, how did it maintain habitable conditions for the last 4 billion years. There's been liquid water on the planet essentially for its entire existence. And even though the sun initially was very faint and has gotten quite a bit brighter, how could there be a faint sun and a warm earth? Puzzles. Plate tectonics provides us the answer. What I find intriguing, it looks as if this is really a businessman in a suit and tie, and he looks like a straight fellow, and the others look a bit wild. It turns out that Newton is not all that wild. He's conforming to the mode of his day. He's wearing a wig. And anyway, he was as much a conformist as was Wegener. The other two I'm not so sure about. Anyway, so we have these two modes of investigating, the reductionist and the holistic approaches. And we've come a long way. So let me just show you what the plate tectonics, so the continents drift, and 215 million years ago they were all together in a huge continent called, I've forgotten the name. Anyway, and I've also indicated various times. It turns out, we can't go into details, but plate tectonics is associated with the carbon cycle. And so carbon dioxide is an important greenhouse gas, keeps the earth warm. And we can invoke plate tectonics to show that this carbon cycle can serve as a thermostat, that if it gets too cold, volcanoes will pump more CO2 into the atmosphere. Rain takes it out through weathering. And rain is more plentiful when the planet is warm and when the planet is cold. And so you see these fluctuations in temperature over the last 4 billion years. And we've experienced ice ages on various occasions over year. Most of the time we've been at a reasonable temperature. These are all the various forms that emerged at different times. I just want to focus on the very recent one. We're familiar with this one the best. So if we go to that picture, the graph looks rather complicated, but every schoolboy knows about the dinosaurs. They disappeared suddenly here. And everybody knows that at that time the globe was quite hot and humid. This is temperatures near the poles, approximately. So the Earth was so hot there were no glaciers anywhere, no ice anywhere.